Alright, Math 1. So let's take a look at this 3.1. Okay. So first we're going to describe attributes based on the graphical representation. Okay, so we're going to find its match, graph, to essentially context. Okay, so let's start with context. I like to start with that. So the amount of money in a savings account where regular deposits and some withdrawals are made. So deposits would be increasing, right? Withdrawals would decrease it. Now regular, meaning it's happening at a pretty, about the same amount each time. So which one of those looks like it's going up at a regular rate, but possible withdrawal? Okay, 2 and 4 are really the only ones that are going up, that are increasing. Okay, now it's going to be discrete, right, because you're not constantly, and that's going to be continuous. You're not constantly depositing money. So it's got to be 4. So 4 would be A. Okay, B, the temperature of the oven on a day that Mom bakes several batches of cookies. Okay, so the temperature of the oven when you're baking cookies. So, does an oven continually get hotter and hotter? No. Does it continually get cooler and cooler? It doesn't, so it can't be going down at a regular rate. It can't be going up at a regular rate. But as you open and close and start a new batch, it's going to adjust it. So if we look at this one, you start heating it up till it hits that where it needs to be. You open it up, cook, open it up, cook, open it up, cook, and so on. So number 1's got to be B. Okay, C, the amount of gasoline on hand at the gas station before a tanker truck delivers more. So the gasoline will be, you'll be losing gas. The question is it continuously happening, or is it always, is it just coming in spurts? Well, you don't continue, if you look at Holiday Oil, it seems like they have a continuous amount of people filling up gas. So it's going down, so it could be 3 or it could be 5. I'm going to hold off on that one. Okay, so watermelons are delivered to a farmer's market every Saturday morning. The number of watermelons available for sale on Thursday. Okay. And then the amount of mileage recorded on the odometer of a delivery truck over a time period. Well, that one we know is going to be going up at a pretty steady rate, right? Because as you're traveling, there may be times when it doesn't, when it's parked, so it'll have some flat times. So that one's got to be D, 2. Has to be E. Okay, so the question now, 3 and 5, they're both going down, but which one would be continuous? Well, I think if we think about it, watermelons are definitely not continuous, so that's got to be number 3, so that would make C number 5. Alright? Okay. Now, we want to find the input or output given a function. So remember, okay, the H stands in for the name of the function, T is the input, then we've got the pattern. So when we put numbers inside, that means we are giving them the input and we want the output. So I go H of negative 4, and then 2, since there's a T there, I go times negative 4, because that's my input, minus 5. Then I don't touch the left side, but I just deal with the right side. 2 times negative 4 is negative 8 minus 5 gives me negative 13. So H of negative 4 equals negative 13. Okay, now let's do C. So now we've got 13. So H of 13 equals 2 times 13 minus 5. 2 times 13 would be 26, minus 5 would give us 21. So H of 13 equals 21. Now in the other ones, they give us the output and want us to find the input. So this time we replace the output in the formula, the H of t, with 23. And that's equal to the pattern. And this time we're solving for the input. So I do the opposite. I add 5, giving me 28 equals 2t, divide by 2. We get 14 equals t. So t equals 14 when input of 14, output of 23. Okay, now last one. h of t equals negative 33, so I replace the h of t with negative 33, equals 2t minus 5. Add 5 to both sides. Negative 33 plus 5 is 28, equals 2t, negative 28. Divide by 2, and we get negative 14 equals t. So that would be negative 14. And that's when we're evaluating functions or solving for the inputs. Alright, now we can do it graphically as well. Okay, so if we look at this, okay, it's the same concept, except our input is the horizontal, output is vertical. So g of 2, I go to 2, go up to where my graph is at 2, find its output, which would be 9. G equals 3, g of x equals 3. Now that means that's my output, so I go here to 3, over to where my graph hits. What's my input? It's 1. So x equals 1. G of 0, input of 0 right here, go up to where my graph is, and it crosses at 1. So g of 0 equals 1. Then it says write the explicit rule for g of x. So remember, explicit is f of x equals a times b to the x, where a is the y-intercept, which we should notice, input of 0, output of 1, there's our a, and b is what we're multiplying by. Well, notice we go to 1 and then to 2, we've got 3 here, and we've got 9 here, and 1 here. So 1, 3 to 9, looks like we're times them by 3, so b would equal 3. So I go, g of x, not f of x. G of x equals 1 times 3 to the x. Alright, number 8, same idea. R of negative 1. Negative 1's right here. Go up to my graph. Looks like its point is negative 110. So negative 110. R of x equals 4. So 4 for my y. Over to my graph. Its x value is 1. R of 2. So I go over to 2, up, and I see that that one equals 1. So if I needed to make a table, I have negative 1, I have 1, and I have 2. So I need to fill in 0, don't I? So negative 1 was 10. When x was 1, r of x was 4, and r of 2 is 1. So what would be this missing number? If you weren't sure, just go find it out. Looks like it's 7. Okay, or we could realize we're subtracting 6 here, subtracting 3 here. Pattern, because it's linear, must be subtracting 3 each time. 10 minus 3, 7. Minus 3 is 4. Minus 3 is 1. So, and this is going up by 1, so slope would be negative 3 over positive 1. So just negative 3. Starting point would be 7. So I go r of x equals negative 3x plus 7. And there's our explicit rule. Okay, now for the rest, we're just going through the motions of inputs and outputs. So f of 4, go up, my y value is 1. F of negative 4, I go up, and I can't really see where it's supposed to be going, right? But I could find the slope. So it looks like I go to the left 4, and then up 3. So to the left 4, up 1, 2, 3, so it'd be to 7. Okay, then the y value, f of x equals 4. So 4, that looks like that's my y-intercept, so x has to be 0. F of x equals 7, we already found what that one is. Its input is negative 4. Okay, and g of x. G of negative 1. Go back to negative 1, down to my graph. My y value is negative 2. G of negative 3. Go back to negative 3, down to my graph. Looks like that's negative 7. Probably be touching at negative 8. Okay. G of x equals negative 4. Okay, there's negative 4. Go over. X value is negative 2. G of x equals negative 1. Go down to negative 1. It's my y-intercept. So x has to equal 0. Alright, last two. H of 0. So 0 right here. Go down. Crosses at negative 5. H of 3. If I go to 3, So then x equals 3. So down, now this one doesn't go to -1, but it looks like it's about halfway, so probably about -1/2 or -0.5. Now let's do the outputs. Output of 1, there's 1, go over to the x would be +4. Output of -2, go over to my graph, go up to x is +2. Okay, d of -5, so I go to -5, go up to where the graph hits it, and its y value is 1. d of 4, go to 4, up where the graph hits at 2. Now do the outputs. Output of 4, go over to the graph, input of 3, output of 0, input of 0. And there we go, guys. So hopefully you did pretty well on that, and there we go.